So, the last topic in this section, we're working with patterns, is analyzing our travel graphs. Remember yesterday we looked at travel graphs, and remember they just measure the distance and time of a trip, right? And we talked about a few pieces of that, and and again, this lesson we've talked about most of it, so we're going to look and see a little bit extra about it. Remember that when you have travel graphs, we have time on the side, distance is the y-axis, right? And make sure you watch out for your units. Yeah? Okay, so let's just go to Education Perfect. We're just going to go through the process. So remember that travel graphs, we use it to understand the motion or movement of objects. So again, distance and time. So talking about how far travel. Remember this one, they don't always start at 0, but they usually should if they're only enclosing that one. What this is showing is that there was some time before the measurement started. Okay. All right. Also remember we talked about the gradient. If the gradient is flat, perfectly horizontal, what does that tell you about the motion? They're not going anywhere, right? They're stationary. If it's not very steep, that means they're moving very slowly. If it's very steep, then they're moving what? Moving fast. Yes. So like on this particular one, you see the one at the very, very steep slope, that means they're going very fast, right? Yes. So if it's a small number, say 2, is that very fast? No. But if it's 25, is that very fast? Yes, and you're going to see why in just a moment, because you do this all the time. So,
excuse me.
So, is it relevant to this? Okay. Now, so let me get finished, guys. So, for example, this guy didn't move at all. So, what do you notice about his distance?
It's the same.
It stays it's 0. It's the whole way across. He's not moving at all. No matter how much time.
Shouldn't it be shouldn't it be at the bottom?
Yeah, I totally agree. It should be. Why?
Because 0 is like the
right. He doesn't go anywhere. It should be at where x equals 0. Does everyone see what she's saying?
So why is it like that?
Should be there. It's just an example so that they can see that you're seeing it's 0, but it's a poor example. Excellent. Good job.
Really
all right.
Rude?
Stationary is a term used. Guys, stationary is a term used for anything object that is not moving. So, do you see a time on this graph where this person was not moving or was stationary? Yes. Between what? Between 4 to 8 minutes, she was not moving, right? Get it? All right, excellent. Good job. So you see there, they're just confirming that. Okay, and again, the bigger the slope, the faster you're moving. The greater the slope, the faster you're moving. So here, does the falcon or snake move fastest? The falcon. You can tell the red line is much steeper, right? So it's easy to compare the two. You're going to be comparing some of them. Looking at this graph, during what times was he traveling the fastest?
From 2 to 4.
From 2 to 4. Why?
Because it's the steepest.
Because that's the steepest part of the line from 2 to 4.
Because 5 isn't.
Because it's like the same, like.
Well, because
No. If you
2
look
to
at
5 or 4 is like.
if you look at this line, it's not as steep as this line. So this one is the steepest of those. So that's where he's traveling the fastest. Okay? All right. Okay. All right. So we're talking about how fast people travel, and so you've done this before. It's called a rate of travel. So like you're driving. If you're driving, what do you measure your rate in when you're driving?
Kilometers per hour.
Kilometers per hour usually, yeah? Okay. Most of these people have been walking, so we've been measuring it in meters per
Hour. Minutes.
minutes usually, yeah, okay. Or you could do hours if they're walking a long trek or something, right? Okay, so those are called rates. And so we have rates of motion. And the rate is simply equal to the gradient. Whatever the gradient is, that's also the rate. Okay? And remember that when you're finding the gradient, you can use any 2 points that are easy to read. Be careful on this one. Look at the scale on the bottom. They're counting in what kind of units? 10, 20, 30. So in tens then, right? All right, but actually they have half units, so they're counting in, aren't there lines between? So they're counting in fives, but they're only marking the tens. And then going up, the first mark is 100, so that means they're divided up into what?
This is 10, 20, 30, 40, 60. So maybe 50.
Ah, yeah. It should be, actually, shouldn't it? Do you see that? Another mistake caught today. That should be a 50, isn't it? Good eyes, you guys. So each one of those marks is 5 minutes, right? But if you look at up here, that's 100. So that's 1, 2, 3, 4, 5. So they're counting in what?
50. I mean, 20.
20s. Each line is 20 meters. So watch your scale. They're really going to get you with scale on these. Look for their errors too. All right. Okay? And again, it's just rise over run. And they finally start doing it right. Look what they did. They measured the rise first and then the run. And yay! Instead of the run and then the rise. I don't know why they did it backwards all this time, and now all of a sudden they decide to do it right.
Education Perfect is a robot, and robots are stupid.
Ah, well.
Don't be
all right.
these slideshows.
Okay, guys.
Excuse me.
Guys.
Mushrooms are
Hello.
stupid.
Okay. So, your units, again, your rate or speed is simply the same as the gradient, right? So, speed of 6 meters per minute. Okay. Watch your units. Okay. And then you get to your homework. So there we are. All right. So